everybody. Um, Great sessions happening today. We have with us Abhishek Das, who is the co founder and CTO of Sourcing Express. And he is here today to talk about traversing from zero to production with graphics. So, over to you, Abhishek.
Again, thank you for tuning into Notes 2025, guys. It's Abhishek here, and I'm from Bangalore, and also I lead New4J Bangalore Meetup group. We have around 6K plus members in the group, and we hold meetups on a regular basis here. We do workshops and try to explore what does knowledge graph bring to the table. And today I'm going to cover a very interesting topic, that is traversing from zero to production. Because all the ideas, like every great ideas, they start with a concept, but when you have to scale it to production for a real business, it is very difficult to scale to production. So having spent 2 years with New4J, I'll be sharing you some insights and insider tricks to get started with New4J fast and go from concept to production. But at the same time, I'm no new for the salesman. So I will be talking to you like a friend or maybe a colleague. So it's not going to be sugar coated anywhere. I'll be talking about what are the real problems that I face with graphs in production, and what are the foot guns that you could be avoiding, and what are the tricks and tips to accelerate your journey and voyage into graphs. So we are all familiar with what Neo4j brings on a very surface level: intelligent operational systems, better prediction for analytics, and definitely with Gen AI on the table, Neo4j brings the best for that. But before diving deeper into it, let's look at what I'm going to cover today. One is I'll be showing you about thinking in graphs, then how to get started with Neo4j, talk something about building a POC, and how to prepare for production, breaking into production, and where do you move forward from there. So let's begin with let's look at how you store databases in traditional ways. So you might be having a MongoDB, you might be having a MySQL or Postgres storing a lot of your data. Okay, your data could be sitting in tables like this, where you have two tables with certain columns which are connected by foreign keys, and you would be always asking, like, how is your data connected between the tables? Okay, so in that case, what happens is you always try to make a lot of joins in your tables and across different documents to bring in all the data. What are you trying to do at the end of the day? At the end of the day, you're trying to derive a graph from all the data that's sitting in your warehouse or any systems that you might have. Different sources of data will be storing different data in different structures. It could be unstructured data, it could be structured data. But at the end of the day, when you have a lot of relationships from where you have to derive some answers, all you're trying to do is just derive a graph out of that data. And what happens with that is your queries become slower day by day. Okay, and they might, take up to 2.5 seconds, up to sometimes, because you might have like around 50 joins, 60 joins across different tables and different systems. But uh, let's see, how do you fix that? uh, so yeah, traditional databases struggle with complex relationships, multiple join operations, and navigating interconnected data seems very difficult when you're talking about interconnected data. Okay, so let's look at how does graph thinking change all of that. So in a graph system, data is stored in nodes which look like bubble, and each of these bubble are represent certain entities. Okay, they might be the same type of entities with a different label, or they could be a different entities with a different label. Let's look at an e-commerce context where you have three types of entities or nodes with labels: person, order, and product. A classic Amazon case where you would have a person named Daniel who has made an order with a certain ID, and the product is having a name called salmon. So what happens in graphs is that you connect different nodes with certain relationships. The line that you see between the person node and the order node are connected with some context, and that context is either stored in the label, just in the label, or they could be stored in additional properties that these nodes and edges would have. Okay. So when you use graph thinking to model your data and store data in a native graph database, you don't question is your data connected. You say how are they connected becomes the main agenda. It's not about fetching data from different system, making all the joins between the table. It's about seeing what is the connection between the data. So that is something which Graph solves at one shot when you bring all your data into something called a graph database. And Neo4j as a native graph database lets you do that very easily. And traversing that data becomes really easy because your data is connected from day one. And whether you want to traverse in any direction, it is very easy to just start with a point and then reach the other end via the relationships. But to get the benefit of that, you need to follow certain organizing principles to make the best use of that. Organizing principles are like schema, which helps you store your data with a certain structure, which helps you bring more context and meaning to your use case. So, as an e-commerce company or as an e-commerce platform, you would have a lot of data. It could be time series data, it could be relationships, it could be anything, almost anything. But what you store in knowledge graphs or graph database is not the same as you store in other types of database like MongoDB or a column database like MySQL or Postgres. Here in graph database, you would be storing the meaningful connection between each entities, the relationship between them, because when you have all type of data just stored inside graph database, it won't make any sense. So that's why organizing principles are very important to speak the truth about the data that you're storing. Okay. And that lets, if you do that, it enables different types of use cases that you can bring. Either it is finding the shortest path, predicting outages in an IoT system where your all nodes are connected together, and you can see what is the potential of outage, or what is the risk factor with certain systems in your mesh. And one of the primary use cases of graph has always been fraud detection, because as the data is connected from day zero, you can always put alerts on certain behavior. And with the help of graph pattern and algorithm, it is really easy to pinpoint what's happening. Are there any anomalies? Okay. Now, where have you seen knowledge graph elsewhere? One of the common sample of knowledge graph is a simple Google search. Say you type any name of any entity, okay, and it brings you different type of knowledge in the right panel of your search. One is that it will give you the description, which are the property of that particular entity, the name, the type, the category, the release date, what is the type of entity we are talking about, all the relevant context to that. And additionally, you can see something that is called the relevant recommendations at the bottom of the search. So you can see here we see recommendations which are around similar entities, which is database. So that's the power of knowledge graph that we have been using for very long. And Google has called it that think, do not think strings, think about things, not strings. Okay. And also in graphs, you have something called semantic relationships, which you can use to represent or talk about your data. Here, if you look at a medical context also, you can store different type of data around a certain drug. What are the effects? Who are the people on whom this drug has been tried? and what are the potential impact, what are the potential dangers. So all of that can be stored and connected and queried when you store data in these relationships. um, Also, let's talk about how do you go from the concept, implementation, and into production. Now that we know that graph databases naturally store data, relational data, you can easily model relationship as they exist without losing any context. And that incredibly fast because as a native graph database, you can traverse the connections very efficiently. And the beautiful part, because graph databases are non-structured, it's a NoSQL, you can easily adapt it to your requirements. Unlike SQL, unlike Postgres, where the data model are very stringent, are very strict, uh, it becomes very difficult when you have different types of data that you want to connect together and store it, because across different tables and joins you will be losing a lot of context, not only while storing the data but also while querying the data. You're going to lose a lot of hidden patterns and a hidden context that becomes very difficult to dig out later on. So, graph thinking is about thinking in connections. It's not about just thinking in tables. For me, after exploring graph database, my mind has completely expanded how I think about data. My perspective has really changed. Earlier, I used to just think data in rows and columns and documents, but when connecting those data, all I was doing is trying to store a graph, but that wasn't the case with using traditional systems. So graph thinking really is required to store data in a manner that works the best for your organization. And how do you query this data? When you try to query that data, we use something called Cypher, which is a language like which is familiar for people familiar with SQL. Cypher is also a similar type of looking language where it is very graphical, it is very intuitive, powerful, and visual for you to query or traverse the data from one point to the other. And you can exactly query what is the exact thing you're looking up for. And when you choose graph, when you have any of the use case mentioned here, like social networks, recommendations, AI applications, fraud detection, network analysis, and pathfinding, and you need those things to work in real time, graphs become one of the primary should be one of the primary ways you should be storing data, so that whenever you have to query that data, it becomes really easy to do that. And the real world impact will give you like 100x faster query compared to traditional databases where you would be joining different tables. So let's look at how do you get started with Neo4j. To get started with Neo4j, I recommend going with Neo4j Aura DB because it gives you a fully managed database in the cloud, which is completely serverless. You don't have to manage anything, run anything on your local system, and integration with different other external systems and with your teammates become very easy when you use or opt in Neo4j Aura. You can get an instance for free which runs 24 by 7 in the cloud, and it is very easy to access and gives you access to more powerful visualization tool and AI features. If you're looking to simulate how would Neo4j run in production, you also have access to community Docker images. And if you're a startup, you can also get access to Neo4j Enterprise via the startup program. Or you can get a lot of credits for the Neo4j Aura. So that's one of the easiest way to get started and get your hands dirty with Neo4j, because the access to barrier is just accessibility. So the Aura DB instance would immediately give you access to fully managed and a full version of Neo4j, which give you access to all the features that are required. And how do you build a POC? So before building a POC, you need to really understand that is graph the right solution for whatever you are trying to solve? And as I said, when there's a lot of interconnected data, it's going to be a graph problem at the end of the day that you want to solve. So at that point, you are very sure that, okay, this is a graph problem. But how do you insert data into Neo4j also matters. So you need to be very thoughtful about what is the problem that you're working with, what is the context that you will be requiring. So based on that, from your existing systems, you'll be using connectors that are available in Neo4j and other open source programs that are there in the Neo4j GitHub that can help you migrate your database from Postgres, MySQL, and MongoDB right into Neo4j. So that is something which will help you to go from zero to some data in your system with which you can experiment, you can do modeling to see how it's going to impact. And you need to really see from day zero if the right context is available inside your database to do a proof of concept with the queries, with the data modeling, with the speed of the query, how the data is getting indexed. So that is something which you need to keep in mind. You have sufficient data that you can sample and insert into Neo4j. So if you do not have that data, what I recommend is installing Cloud Desktop on your device. And Neo4j has got Neo4j MCP, which lets you connect to your Neo4j database, and it gives you access to write, read, and querying the schema of your database directly within Cloud Desktop. You can also use GitHub Copilot inside your Visual Studio Code, Cursor, or any other agent which is MCP compatible. So Neo4j can help you easily connect it to your LLM like a USB and start working on your database. I use Cloud Desktop and Neo4j MCP on a regular basis to help with data visualization, uh, data queries, helping me write Cypher queries, or even model my database. So it is a completely AI assisted pipeline which helps me increase the value of my knowledge graphs that I'm deriving on a day to day basis. And also, it lets you create mock data from thin air, almost thin air. Because it has a lot of training data with a lot of sample in it, it can help you easily go from zero to some sample data in like a matter of minutes. All right. Uh, Next thing is going to be after you have some sample data, you can ask the same agent to help you create a client also. So client can be created with say Python, JavaScript, and Java obviously, because Neo4j has first party and excellent support for Java programs. So you can use that same thing, same LLM to, based on your model, create a simple API endpoint or a program where you can connect and see how you're querying the data or how you're retrieving the data, how you're making the inserts. So that all also is AI assisted. So for me, when adopting Neo4j into our organization, we extensively use Cloud Desktop to help with the modeling, with the migration, and also with experimenting what can be done further. Because ROI from knowledge graphs doesn't end anywhere. Till you have more and more data that can be used, more and more context that can be stored semantically, the ROI that you can reap from knowledge graphs is endless. Your imagination and your data that you have is the only limit for you to derive any value from your knowledge graphs. Uh, but one thing about graphs is that because you have data stored in properties and edges, right? I mean, you have properties that are storing additional data. Sometimes you would have a knack for storing documents also inside Neo4j, but again, that's not the right pattern. If you want to store extra metadata which should not be there in relationships or nodes and edges, at that point you should be utilizing something different that Neo4j offers. So when trying to store JSON in metadata and you want to be also be able to query that, uh, Neo4j obviously allows you to store that in a string, but then again it's a little difficult to sometimes query that data. So Neo4j has something called APOC, which is called Awesome Procedures, okay, which lets you extend your database to do anything beyond your imagination. Uh, it can let you run a Java program right inside Neo4j to extend the capabilities, or you can utilize 100 plus APOC libraries to add more data to your and add more features to your database. So you can just search Epoch Neo4j, and it will help you with a lot of extensions that will accelerate your workflow and bring more features to your Neo4j database. Whether you're working with vectors, whether you want scheduled jobs, or you want a different system that is going to poll another system or run some triggers. For all of that, you have APOC to help you extend the capabilities of your database. And one of the remarkable APOC procedure is the Redis and the MongoDB connector, which has been a very useful connector for me, because sometimes you need to store additional metadata in documents which should be again be queryable. So in that case, because Cypher queries are so powerful and intuitive, you can just let your Neo4j talk to external systems at the same time, and then extend the data that you are able to retrieve at the end of the day without even using any other application. So that is one of the most powerful and my favorite features of all time. That is the APOC procedures, which can let you connect to external systems and also extend the database to run certain Java commands or Java programs on your query or your database. So that's like one important point where people get it wrong. Some of my folks from community, they have tried to store documents inside Neo4j, and that's one of the biggest foot gun. Okay, if you're trying to store documents, you need to see what needs to be there in the graph and what needs to be just be available as a metadata. Sometimes you might get away with a string. Sometimes you can use the APOC procedure to connect to external systems and retrieve the metadata that is required for further use inside your application. Now, prepping for production. Uh, After you have done the concept and you see it is working now, you before going to production, you have to be very careful about certain things. Okay. One is that knowledge graphs require extensive care, because once you have data in a knowledge graph with a certain organizing principle, your applications would also be tailored or would also be following the same schema and structures and also DTOs that's going to be using that data, right? That data structure that you have formed. So when extending or modifying your knowledge graph, you have to be very careful how you migrate those stuff. So while doing migrations, you can either do a roll forward migration or a rollback migration, but both of them comes with their own trade-offs. What I found useful is to do roll forward migrations, where you suppose I have to migrate the name of a certain a property. In that case, I will have to copy that property name, and also at the same time, my application has to do it until we do a roll forward. If the roll forward is not complete, in that case, I can risk my knowledge graphs to be completely compromised, and that can affect your other systems as well. So, how you plan the migration matters a lot. And the other thing is regular backup of your knowledge graph is very important. Uh, so what happens in Neo4j Aura is that you have regular backups that are available inside Aura DB that comes by default. So you can have good point in time backups. But if you're using Docker or if you're self-hosting it, then backups are your own responsibility. And either you use a change data capture that's built into Neo4j to create a replica, or you use Neo4j admin tools to back up your database. You'll have to be very careful if your backups are there or not. Because if your knowledge graph gets compromised, in that case, you need to have a certain backup to restore to that. So we have made a lot of errors while working on knowledge graphs, where it led to our application downtime because we didn't had proper backups and we didn't use the right migration strategy. You would be having data connected with different databases, not databases, I mean different backend systems. So a good migration strategy is always recommended. I recommend using the change data capture feature that's available right inside Neo4j, which lets you listen to changes and either back up the data or stream it to other systems where it's required. And the CDC is one of the most powerful features that Neo4j has today, and you should definitely put it to use to power real-time systems.
Hey,
Uh,
Abhishek,
yeah.
a quick time check. So we are about 2.5 minutes to the end of the session. Just wanted to let you know that. So if you have any
Yes.
Q&A, you may want to take that up too. Thank you.
Yes, I'll just finish the last topic. Uh, and preparing for production also requires you to take care of most important thing, that is our backend policies, because in knowledge graph, as everything is accessible and very easily traversable, you need to be very careful with whom you're giving access to your database. Neo4j has got very powerful RBAC policies that you can enforce and make sure that the right user has the right access to the right data, limited data, and also logs are available inside Aura DB to help you with that. Uh, and definitely, if you have different deployment strategies, your database integrity and security also landscape also changes different across different systems. So try Aura DB for enterprise, and it should be taken care of by Neo4j. And yes, definitely hit the production after you're all set. uh, and also monitor the changes from day zero, that is it fast, if you're getting the gains. Start small with a concept and prove the value incrementally. Model first, and the design matters very much. If your knowledge graph is not designed properly, it's not going to yield that result. And also monitor the performance, that if your indexes are working properly, if the queries are within sub milliseconds or whatever is your requirement, right? And start your graph voyage. The journey begins with a single node. So yes, that's the session again. And moving forward, use Graph Academy to learn new Forte and get hands-on experience doing the courses. And if you are here in Bangalore, do join our meetup group. Also, spread the words, Notes 2025, and Graph for the win. If you want to connect me on LinkedIn, there's my QR. And thank you very much. All
We
right.
will.
We can we do a small Q&A?
So we are over time, Abhishek. So maybe you would like to share your contact details on the chat, and people can attend. Our attendees can connect with you. So if you send that over to me, I could put it on a chat. But thank you so much. Thank you so much to Abhishek and our attendees for your valuable time. We are now ending this session, and we'll see you in the next one. Please don't forget to complete the feedback survey before you leave.
Thank you, everyone. Good to have you all. See you around in notes.
Thank you.
Bye.
Bye.